So, me and Radhe, while we were going through this sixth class textbook of mathematics, we found something very interesting. And I was tempted to share this entire thing that we learned today with all of you. There is this chapter here in this book. This is mathematics class 6 book, and the chapter is whole numbers. The page number would be 36, and it has a very nice question actually. So before I go into the solution aspect of this question, I would want to emphasize upon the approach, so that if you can build such kind of approaches around the questions that you come across while you are still growing up, that might very well help you in applying mathematics in the field, in life actually. So that's something that I have been very fond of, and very frankly, I picked this up very late in my career when I tried applying mathematics to the real life problems. So that's what I try to delve this habit into Radhe, where I try to insist or emphasize upon how would you see this problem in terms of mathematics. So this was a very interesting question, and that's why I felt that it would be this problem deserves to be spend some afternoon time. And frankly, me and Radhe spent some. In fact, it took me around 45 minutes to solve it, and Radhe, with a little assistance, he was able to solve it as well. So I just would very briefly try to give you a perspective of the approach that you may need to develop, so that it helps you in your future. So this question actually is very interesting. It says that, let's say if you and your friend are playing a game, and this game is like either of you have to pick numbers ranging from 1 to 10. So either of you can pick numbers from ranging from 1 to 10, when 1 and 10 are included. And what you do is that the game starts with you. So you pick a number between 1 and 10, and then you give that number to your friend. Your friend again, he is free to pick any number between 1 to 10, and he adds the number that he has received from you, and the one he has chosen, and then he gives the sum back to you. So your friend then gives you the sum back. Now again, it is iterative. So what you do is, then you again choose a number between 1 to 10, and then you add that number to the sum that you received from your friend. And then once you choose that number, you add that number to the sum you received from your friend, and then give back that sum to your friend, and this continues back and forth. And what is required in this problem is that it says that what should be your strategy so that you win this game. So excellent question if you look at it, because see, I personally feel that there are two ways of approaching a problem. One way is the straight way, which in terms of, if I would like to if I were to relate it with the computer programming world, it is the iterative way. And then there is a recursive way. The recursive way is a way wherein you say that, okay, I've actually reached the situation where I have the solution, and then I backtrack myself. And that's an excellent approach if you can, because that's something which usually when you get into engineering classes and all those higher studies, you develop this habit of thinking in those lines. But as a child, when you're growing up, if you can see things in this way, then it will definitely help you when when you are going to apply mathematics to various fields of life. So this problem, I do not know how one could solve it if he has to think in a in a way where he begins with the problem and then tries to reach to the solution. Me and Radhe, however, what we chose is, let's start with the solution. Let's assume that you have won, and now try to backtrack it. And that's one of the most, I come from a computer programming background, and this is like, this is something which usually is done when you're solving big problems. If I were to give you an example of it, that would be, so one of the examples which you may frequently see where such approaches are applied is like, when you book a cab or something and you're driving somewhere, and it gives you a distance between your place and where you actually are. So that's one of the problems where a heavy amount of mathematics with this approach is applied. Usually in programming world this is called recursion. However, we're not getting into it. But my entire intention of sharing this video with you is that if you could also think in these lines and try to build your approaches, that may help you in the in solving various different problems which are very difficult. If you were to apply them, if you were to solve them without applying such ways of solving it. So let's try to see it on the board. How does it look like? So let's say if my name is if Radhe and me were playing this game, and supposedly Radhe starts the game. Let me put the other pen. So let's say if Radhe and me were to play this game, right? And the intention is that Radhe wins this game because he's going to start this game, and we need to develop this strategy wherein we say that what should we do, wherein if Radhe picks up a number between 1 to 10 initially, and if his friend, which is actually me, is also free to choose number between 1 to 10. So in what ways should Radhe be constructing his or picking up his numbers in each chance that he gets, so that finally he gets to win? At this position, let's say at this nth, let's say if this is how it starts, this is the first time, this is the second time, this is the third time, and so on and so forth. And let's say at the nth time Radhe wins. Okay, so let's, before I actually get into the solution aspect of it, let's see it in the real life. How would this happen, right? So it's like I choose a number, Radhe picks up any number 4, I pick up any number, let's say between 1 to 10. Let's pick 10. So if I pick 10, the sum becomes 14. So I get back 14 here. Then I'm free to choose any number. Let's say I pick 5. So I give back, Radhe gives back 14 plus 5 to me, which is nothing but 19. And I get 19. And then I choose any number between 1 to 10. So that would be, let's say, 3. So if I choose 3 here, this becomes 19 plus 3. That would be 22. So I give back 22 to Radhe. He's free to choose again number between 1 to 10, and this continues. So likewise, and what we want is that finally this guy should win. That's what our entire intention is, that what should be the strategy in picking up these numbers so that this guy wins, the one who starts this game. Right, so this is the way which usually people would approach this problem. This is the straight way. In a programming way, somebody would call it an iterative way. An iterative way is nothing but you pick some number, you try doing this, then you come up to a situation, and then you determine whether this guy is winning or not. And if it doesn't, then you continue again with some different values, and you keep continuing this. Right? So that's an iterative way of doing it. And as you can understand, if you start picking up some value here, then this guy picks up some value, and then you try to come up finally and see who gets to the sum of 100 first. That is going to take a hell lot of time, and frankly I could not think of any solution in those lines. All right, so what I would recommend you is that before you actually listen to this entire solution, I'll give you a hint to this solution, and I would suggest you that take this hint, take your pencil and paper, sit back and try to do this, and then probably you can get back to the solution. But I would strongly recommend you that after I give you the hint, just try to think in those lines, because that's that should help you, and probably if you go the logical way, you'll definitely reach the solution. So the hint in this case is, let's say if these two guys start this game, and whatever may, whatever number they may begin with, whatever number this guy begins with, he gives it to this guy. He picks up that number. He adds that, he chooses a number, adds the number that he's received, and he gives it back to this guy, and this thing entire, this is how it continues. Now, what is the intention? The intention is that when this guy gives back a number to this fellow, and supposedly this is the winning condition. This is where this guy says that, okay, I've won the match, right? So this is the end condition that we're talking about. So think in these lines. We are ignoring all these steps here. Now what we are focusing here is the final step. So, in mathematics we would say that this entire thing may have gone n times, right? We do not know how many times this may have happened where they've exchanged the numbers with each other. So we say that this has happened n times. N is some number that we don't know yet. How many times these guys have exchanged the numbers, we don't know it yet. So supposedly we've reached this condition, assuming that we've come over here. Now what happens over here? When this guy receives a number and he says that, okay, I've won. What kind of a situation it would be? Definitely, if you go, if you go a step back at this point, this is the ultimate step. If you could go back to the penultimate step, the step just before this ultimate step. At this point, this guy would have felt, he's kind of helpless, because he has the ability to pick up any number between 1 to 10. Now, he definitely would have given a number to this guy which would either be 90 or greater than 90. Okay, so at this step, this guy would have given a number to this guy which would be 90 or greater than 90, because in that case only he could claim to be a winner. Supposedly he gets a number 90, the sum 90 to him. He's free to choose number between 1 to 10. So he chooses 10, that makes it 100, and he wins, right? But if he gets a number 89, then he can't win, because then he's, whatever number he chooses between 1 to 10, that would be, the maximum, the sum that he may be able to achieve would be 99. That would be less than 100, and he'll have to give it back to his, the other fellow, and he would win. So that's the, that's actually the crux here, that at this point of time, at the step which is just before the ultimate step, this guy should be giving him a sum which is either 90 or greater than 90. Now, okay, cool. So mathematically, if I were to write it, assuming that at each step these guys have picked up numbers which are like A1, A2, or rather, let's not get into the, I would rather not pick my solution. I would rather choose the solution that Radhe used to solve it. So we'll use that solution, because if I were to use a little, mathematical terms here, then it might get a little confusing. So, and this is not an advanced mathematics problem. It is a problem which is solely based on addition and a little logical thinking. That's all it is. So it doesn't have to have any advanced mathematics in it. All right. So let's keep it very simple. Okay. So this is what we just discussed, that at this final, the final time when this guy gets the sum from the other guy, he, if he gets anything which is between 90 to 99, and this is this condition that we're saying that this is where the game stops. So we're going to the end condition, right? So we say that this is where the game stops. So definitely if he has to win, then he must get a number which lies between 90 and 99. Then only he can pick any number between 1 to 10, add it to any of, any number which lies between 90 to 99, and get a sum of 100. And that way he will win, right? So here the thing is that what you need to understand is that if this is my final step that this guy wins, what is going to be my penultimate step? How the things would look like in the step which is final -1, which is this step. So what it means is that at this step, this guy should be making a number between 90 to 99 after choosing his number between 1 to 10. So once whatever is received at this step, let's say he receives some number S here. So when he says S plus his number between 1 to 10, whatever he may choose, his number, if I were to write it in plain English, sum that he has received plus number that he has chosen number, this should lie between 90 to 99. So this is the condition that you want to make here, right? Now what we're trying to do is we are trying to backtrack it. Now what is S then? We need to figure out what is going to be S in this case, so that we know that this chosen number could be anything between 1 to 10. So we backtracking it, right? So here we've come to this state. We've gone, we've identified this state. We've identified this state. Now we're going back. Now we need to identify what happened here. What was chosen by this guy so that this number S, this sum which got over here, limited this guy to make a sum lying between 90 to 99 only. Now if you look at it, if you want to achieve this case, there is only one thing that has to come over here, and that is there is this number. The reason why you have to fill this blank with this number only is, let's suppose if you do not choose 89 here, if you were to choose 88. If you were to choose 88, this guy, if you come over here, he could have chosen 1, and in that case that would be 88 plus 1, and that would be 89, and this condition that you are trying to meet would not be achieved. And to make this happen, you need to have only there is going to be only one number which when chosen would make this situation happen, and that is going to be 89. If you can put your head around this, then this is where this problem finishes, right? See, you started off from here, from the end, you went back a step, you identified what is going to be, what things would look like at this stage, and this is what you figured out. And then you went back in the past again and tried to see that what should be the number here which should be able to make a condition like this here. So this is the only number that will make this situation happen here. And that's where this problem finishes. So this is how this entire solution would look like. What we've identified is that 89 is where the number that this guy generates at his previous attempt. So we'll continue from here then. So now that this guy knows that I want to make a 89 number, and I will give, once I create a sum of 89 to this guy here, I will have this condition met where this guy would only be giving me 90 to 99, and therein in the final state I would win. So this is how it would look like. This guy should be making a number 89 from whatever he's received from this guy. Now we as we saw in the previous video, we try to climb up the tree. Now we're doing the same here. We're going back to how things would look like if I have to get a number 89 here. So if I were to get a number 89 here, it means that this guy should be sending me a sum which ranges between 79 to 88. And this guy gives me a number ranging from 79 to 88. I can make 89. Let's say if he gives me 79, I can add a number 10 to this and I get 89. If he gives me 88, I can add a number 1 to it and get 89. If he gives me any number between 79 to 88, which let's say is 70 or maybe 85, I can still make 89, right? So my intention is to make 89 here. So whatever I've received from this guy, but I need to have a valid a kind of a limitation on this guy, saying that he has to send me a number which ranges between 79 to 88, right? So let's suppose we've done this, we go back here. So this guy, it means that this guy, if he has to make a number between 79 to 88, okay, so this way I have to, so if I come to this situation here, I'm going back a step again, and what we are intending to do is we're going to reach here. So we'll be climbing these stairs. We're going back. This is a bottom top approach. So we're going from, assuming that we've won. We're trying to climb this ladder. So now, if this guy has to give me a number which ranges between 79 to 88, then I need to make sure that he gets 78. Because if he gets 78 and he has to choose a number between 1 to 10, then definitely whatever he chooses, that is going to fall within the range of 79 to 88, right? So that's where you come back over here and you say that, okay, this winner, supposedly the winner is, is the guy who's saying this. So he says that, okay, I am going to give a sum of 78 to this guy, right? So he needs to ensure that whatever he receives from this guy, he is going to make a sum of 78 and give it to him. Now, in order to make 78 at at this stage, what does he need? He again will have to kind of say that to make 78, I would need numbers coming in from this guy which range between 68 to 77. If he gets any number between 68 to 77, he is free to make a 78 here, right? So we come over here and we know that this guy can and to restrict this guy to give him a number which ranges between 68 and 7. So whenever I say number, it means the sum. So he gives him a number ranging between 68 to 77. He needs to you need to kind of restrict him, saying that, okay, if I give him 67 at this stage, then whatever he chooses between 1 to 10, he's always going to give me sum ranging from 68 to 70. Alright, so in order for this guy to come to 78 over here, you need to restrain him sending only a sum of numbers ranging between 68 to 77. Now how do you do that? Then you come back, you say that, okay, if I give him 67, then I've kind of restricted him to make a sum which ranges between 68 to 77, right? So that's how you will climb up these steps, these ladders over here, and you'll come to a situation where it boils down to this starting position. So as you can see, what we've done is that we started from the bottom, gone up, right? That's it. It's a different paradigm altogether. Now, what have we concluded? If you look at this table, what have we concluded? We've concluded that whatever number this guy starts off with, you can check this at your home also. Whatever number you start off with, and let's say whatever it was, 7, 4, 3, whatever he may choose from 1 to 10. This guy over here, he is free to choose any number. You can't restrict him, right? We can't restrict this guy. This is not in our control. So he can choose any number between 1 to 10. So whatever he chooses, what we get as a sum, let's say he started off with 4. This guy chose, let's say he chose 5. Right? So 4 plus 5 is 9. So 9 is what he's going to give back to this guy. And what he knows that if I make a 12 here, what I need to make a number 12. So 9 is what I've received. So I'll choose 3. So if he chooses 3, the sum becomes 12, and this 12 goes to this guy. And what he again can choose whatever number he can, and he can add that number to 12, and he will give it back to this guy. And he needs to ensure that whatever number he chooses, the sum then becomes 23. So these number over here, what they represent is the sum that this guy needs to make. So he needs to choose wisely, so that whenever he chooses, the sum is any of these numbers, right? So that's how it is. So I would just try to test it. See, if this is the approach you follow, this is the strategy if you follow, would you always win? We tried it a couple of times, you know, with some random numbers that we picked, and you know, we were able to prove this theory. So if this guy always, you know, tries to make these sum whenever he gets a chance, his attempt should be that whatever number he chooses, that number should be making a sum, you know, which is one of these numbers, you know, whenever he gets the term, one of these numbers here, that way he's definite to win the match. That's kind of an interesting question. So, you know, before you actually go, you know, and believe this, try to do it, and try to see, you know, what you know, eventually you have arrived to. So it's a you know, it's solving a problem in a different, with a different mindset, where you are trying to go a bottom top approach. So you know, it's kind of a very interesting, you know, way of dealing with things, and I hope you guys can, you know, if you can pick this up and try, you know, seeing such problem statements around you. A lot of things that happen this way, you can, you know, find a solution very easily using this approach. If there's anything that you guys would, you know, have a confusion on this, I'll be glad to take your questions. See you.